Good morning to all of the attendants of the third B Annual International Conference on Informatics, Technology and Engineering 2021, which is held online for this 2 day on August 25 until 26, 2021. Thank you very much for your time and willingness to listen to our research about real-time monitoring design for make-to-order industry. In this today's session, the discussion will be divided into four main sections, which start from introduction, that will be followed by the research methods, the implementation, results, and also final conclusions. So, first of all, I'm going to start with a brief explanation about this research. The object on this research is a make-to-order industry that have a unique working process due to the high variety of products. The main idea is to design a real-time monitoring device for cost estimation that is estimated by calculating machining time. As a result, four alternatives were proposed to get three main data, which are operators data, parts data, and also machines data, that will be explained further in the next session. This research would give impact to create an accurate cost estimation and production time predictions. The production progress can also be monitored to get the insight necessary, such as calculating operators' incentive based on the performance monitoring. Okay, so basically, in order for the system to work on capturing production activities data, there are three main segments, which are data collections by the IoT device sensors, cloud for data processing, and the integrations to the company's ERP. To support the data collections, three sensors are used to identify changes on the shop floor that will be translated by the microcontroller ESP8266, and then the data will be sent through the internet to be processed by the cloud and visualized on the company ERP system and dashboard that is integrated throughout the system. So, in order to get an accurate data collection for the device IoT, a working scenario are created to ensure that all data flow works properly to minimize error. So the scenarios are then depicted on this figure, where operators have to follow these few steps while working on the machining process. The first one would be operator's card tapping to track the operator's location. That will be followed by turning on the machine and taps the parts card to identify parts location on the shop floor and starts the cycle time calculation. The operator can then start the machining process by turning on the spindle. And yes, operator can do a setup in the middle of the machining process. After all the work has done, operator have to tap the parts card for the second time to give a status that the machining process are finished, so the cycle time calculation are stopped. The operator can then turn off the machine and report to the dispatcher. All of the changes that happens within the process are all recorded with the system as process. Consecutively, the recapitulation can then be obtained accurately. So, to get the overall accurate data collection, four alternatives were proposed within this research. So there are two main points that act as the main consideration for this design. The first one would be the electronic component availability on the local market, and also the price tag in Indonesia. The second one would be seeking for a product benchmark that already exists in the market and have the same feature and capabilities based on the research need, and also available in the market. All of these proposed design have the capabilities to be connected to the internet. So in order for all of this device to work properly, an internet connection would be necessary. So as you can see, from all the alternatives, the first, second, and third alternative are produced with local electronic components. So it has to be assembled and programmed from scratch. While on the other hand, the fourth alternative has their own product line. So it is very easy to install. It also provides a plug-and-play feature, and they are fully configurable. But the fourth alternative itself is only available through online order outside the country of Indonesia, so we have to pre-order online and ship it through Indonesia. The first alternative uses relay as its main sensors and gives an accurate data for machining time, while the second and third alternative uses electromagnetic current sensor that is more cheaper and also have the same capability. The only differences are in the main microcontroller. The fourth alternative, on the other hand, also uses a current sensor, but the data are sent through the gateway and directly sent to the cloud to be processed, so it is more efficient and easier.
To give an illustration about the main logic for shop floor activities, the logic gate is designed for spindle, machine, operator, and part. The input data are spindle status, machine status, operator ID, and part ID. There are two tables that explain about truth table. The first table identifies the productive time and non-productive time for both the machine and the operator. The second table determines the productive time and non-productive time of the system. There are three types of productive time. First, when the operator is processing a part on the machine. And second, when the machine is processing a part automatically. And the third, when the operator is conducting non-machining operation or manual operation. The testing results in the comparison benefits and trade-off for each alternative. The benefits and trade-off are summarized during the testing, implementation, and group discussion within the industry counterpart. Alternative 1 has more precise result compared to the other alternative. Alternative 2 has economic advantages only if the time lag is tolerable. And alternative 3 has flexibility for development with the addition of supporting components because it has more input and output pins, while alternative 4 is suitable for quick installation and the number of machines is limited. This comparison can be used as a consideration for companies to choose which alternative can be implemented. The device designed on this research is charged through a power source and periodically sends data to the cloud. Figure A displays a step function displaying the state of the machine and spindle by utilizing a contact relay, while figure B and C displays the analog signal of the electric current detected from the machine activity by utilizing current sensor. Beside the IoT system, another cost trigger is from software and cloud services. To support the data integration process with the cloud, software and cloud services are needed. The table shows the specific software and cloud pricing scheme. In this research, an alternative method is currently under development to utilize the existing cloud server owned by the SME. The integration of ERP involves API, cloud, and database that is integrated to show the dashboard designed in this system. The dashboard visualizes the information that consists of operator's ID, part ID, and position, productive time, and non-productive time. Applying two types of sensor, first contact relay or current sensor for machines, and second one is RFID for operator and part, enables identifying machine productivity and operator productivity. Machine and operator are critical resources in MTO. As seen in the previous table, the implementation of the real-time monitoring system is sensitive to the number of IoT transactions each month. Depending on the type of product and average machining time of each process will decide if the MTO industry is viable to run a cloud service or, in the long run, invest in an internal cloud service of their own. This research is currently setting up an internal cloud service as an SME having short processing time. Thus, data transaction is high. In conclusion, there are three main points to summarize from this research. First, this research proposed for alternative that has different advantages and is suitable for different situations depending on the precise level of monitoring, the availability of programmer resources, and also the risk to modify current existing machine. The proposed monitoring system utilizes components, devices, and modules that are widely available in the market. And finally, the proposed monitoring system can identify the productive time of the machine and operator, regardless of the various order machines and operator in the MTO industry. Okay, so that's all the presentation about real-time monitoring design for make-to-order industry. Thank you very much for your attention. Good morning and have a good day.
Hello everyone, it is great opportunity to present my paper at the third InCITE 2021. My name is Gunawan from University of Surabaya. I would like to present my study titled Community Mobility During COVID-19 Pandemic and Tourism Performance Data Mining Approach. Technological innovation has entered all economic sectors, Hospitality and leisure industries within the tertiary sector experience a significant impact of technological innovation. Travel booking technology is evident in how the tourism industry is growing around the world. Some technologies, such as mobile technology, augmented reality, recognition technology, the Internet of Things, and big data, continuously affect tourism trends. The movement control policy and limitation of flights have nearly stopped visitors to tourist destinations. The World Tourism Organization reported that international tourist arrivals in the Asia-Pacific regions suffer a 94% drop between January to March 2021 compared to the same first quarter of 2020. The World Tourism Organization defines tourism as a social, cultural, and economic phenomenon when it entails the movement of people to countries or places outside their usual environment for personal or business and professional purposes. It emphasized that tourism and people's movement or mobility are intertwined. This research depart from this basic notion. During the over 1 year pandemic, starting March 2020, the movement control policy and social distancing campaign have changed the community mobility. Google published community mobility report with daily time series data starting from 16 February 2020, covering 6 areas. 3 areas, retail and recreation, transit and station, and park, could be considered as tourism-related areas. The question is whether the community mobility change or fluctuation relates to tourism indicators from years before. The answers might add understanding about the independent tourism-related variables explaining the mobility fluctuation during the pandemic. The study focuses the analysis on all 34 Indonesian provinces. The specific objectives are: first, to present the nature of community mobility fluctuation at the tourism-related area. Second, to group province based on the similarity in mobility fluctuation and tourism-related performance. And third, to characterize province across the tourism-related performance. This study applies secondary research. The figures on the left present the research framework. Mobility fluctuation at retail and recreation, transit and station, and parks are data during the pandemic period. Data of tourism-related indicators are data before the pandemic, which is year 2019. Analysis of mobility fluctuation and tourism indicators among provinces is targeted to explain mobility fluctuation. The data mining process produces a clustering model that can be used as a predictive model for other dataset, which are 2018 and 2017. The application of the model to the year 2018 and 2017 data is aimed to observe whether there is a change in the grouping of province or clusters. The study adopts the data mining method, which is implemented using a process framework. We can see the figure on the right, CRISP DM, The CRISP DM stand for Cross Industry Standard Process for Data Mining. Here are the 6 steps, from research understanding, data preparation, modeling, evaluation, and deployment. There are 2 data sources, the first is community mobility reports with 3 variables, retail and recreation mobility, park mobility, and transit and station mobility. The second data source is the National Statistics Agency, BPS. We get 4 variables, length of stay in start hotels, length of stay in non-start hotels, the occupancy rate in start hotels, and the occupancy rate in non-start hotels. The figure exhibits a NIME workflow to clean and normalize data. Okay. Now we come to the result. Mobility change of retail and recreation, park, transit, and station are plotted in weekly time series. Daily data is collapsed into weekly by calculating mean values. We can see the vertical axis represent the percentage of mobility change. Figure on the left is retail and recreation mobility change. The fluctuation tend to the negative or decreasing direction. You can see minus 60 on the left. Okay. The right figure for park area. We can see also the mobility fluctuation. The highest point is 54 increasing, and the lowest point is minus 100. But from the figure, we can see it looks the decreasing, the mobility fluctuation. The next figure is for transit and station mobility fluctuation. From all 3 figures, we can see that the fluctuation change it happened during the March, last year, this because of the mobility limitation, that we call as PSBB at the time, So the PSBB has impact on changing the mobility, community mobility, So the community mobility can see decrease sharply during March 2020. Okay. In addition, a sample of 2 provinces, Bali and East Java, is presented in the right figure. It is apparent that transit and station was showing the biggest mobility change. We can see TS, transit and station. Followed by park and retail and recreation. Bali experienced a higher mobility decrease than East Java, and it is realistic as Bali is a major tourist destination. As the unit of analysis for further modeling is a province, the mobility fluctuation in the time series was transformed into a single value for each province. the root mean square of mobility fluctuation for each province was calculated. Descriptive statistics were performed using the statistic node in NIME workflow. This table shows that transit and station has the highest fluctuation and mean value. It implies that during the pandemic, this area category experienced a higher decline in mobility. This result is reasonable as the limitation of public transport operation and movement control policy in general. That Indonesia, last year we have PSBB, and now PPKM. Based on the type of 7 variables, the modeling belongs to unsupervised learning. All data is numeric scale, so clustering method is the appropriate one. And here K-means algorithm is selected. The evaluation of the appropriate number of K was performed using the silhouette coefficient. This coefficient has a range -1 to +1. This table presents the silhouette coefficient for each cluster component and mean for K equals to 2, 3, and 4. It appears that the highest value is K equals to 2. So this is selected for K equals to 2. K-means clustering was performed to produce two clusters. One small cluster contains 6 provinces, and a big cluster has 28 provinces. As shown in this table, the small cluster consists of Bali, Yogyakarta, and Jakarta, well known as a domestic and international tourist destination. In addition, North Sulawesi with Bunaken National Marine Park, West Papua with Raja Ampat, and Rio Island are also popular tourist spots. ANOVA test was performed to investigate whether there is a significant difference between clusters for each variable. This table on the bottom shows that the mean value of each variable for each cluster and the ANOVA test. It shows a high significant result with a p-value less than 0.001 for 4 variables, less than 0.01 for 2 variables, and less than 0.05 for 1 variable. Cluster 0 has higher mean value for all variables. So overall, this result proves the difference between both cluster. The small cluster with 6 provinces has both high mobility fluctuation and high tourism performance. It is reasonable, for example, Bali and Jakarta have high tourism performance indicated by visitors, length of stay, and hotel occupancy rate. The result is likely to show that provinces with high mobility fluctuation are those with high tourism-related performance. So it is apparent that tourist destination province experience tremendous mobility change during the pandemic. Okay. Next is model deployment. Modeling and evaluation phases of CRISP-DM have produced the K-means clustering model. The model was applied to the past year's dataset to see whether provinces were grouped in the same cluster as 2019 or not. The shifting of cluster membership could indicate the significant performance change in the tourism indicators. This figure exhibits a NIME workflow for model deployment. First, the Excel reader node reads the tourism performance of 2018, yeah, or 2017, yeah. Then applies the model with PMML reader to predict, yeah, with PMML predictor the cluster membership of the data, yeah. The analysis indicate, yeah, the same result of cluster membership with the 2019 dataset, yeah. So it show the validity of the PMML model, yeah, and it indicates the non-substantial performance change within tourism-related indicators, yeah. So it means that uh, we can say more or less the same, yeah. The performance of province within cluster is more or less the same, yeah. Okay. The study has completed the three objectives. Previous study explained that the mobility fluctuation, yeah, relates to the community mobility policy, yeah, such as PSBB in Indonesia or PPKM, yeah. Uh, the study shows that the intensity of mobility change during the pandemic could be explained also by the tourism-related indicators of previous years. Yeah. The study has added the literature on the application of data mining to macro socio-economic studies. While the application is considered simple, yeah, the study shows the contribution of the data mining to relate data from different sources, which are Google Mobility and Indonesian Statistics, yeah, from different types, time series and static, to achieve a better understanding of the actual Indonesian condition, yeah, in the COVID-19 pandemic. Yeah. The finding is limited to the Indonesian context. Further study might extend the scope to other neighboring countries to find a better generalization of this finding. Yeah. Finally, this study suggests that tourism academia adopt a data mining or data science approach to reveal the meaning of the increasing volume of tourism-related data. Okay. Thank you for your kind attention.
So good afternoon, ladies and gentlemen. My name is Hans Tanto, a representative from submission paper number 35. And today I would like to present about the paper that I wrote together with my professors with the title Simple Heuristic for Scheduling Apache Airflow, a case study at PTX. Here is today's agenda. First of all, I'll discuss about the introduction or the background regarding the Apache Airflow and how do we come up to this paper, and it will be followed by the literature reviews that we had before we formulate the heuristic approach that I will discuss deeply in the chapter 3. And last but not least is the conclusion part to summarize the whole concepts of our paper. Without a further ado, let's just make a start from the introduction or the background. First of all, I believe that almost all of us have been familiar with the terms of the big data. And we also realize that the big data is really powerful for the company to have the well-informed business decision. But the challenge is actually how to manage the interdependence issue as well as how to utilize the data for the relevant analysis. We know that the relevant analysis will need the data to get updated on a scheduled basis so that it can be used for the well-informed business decision. However, the next challenge is how to minimize the manual work that is really painful in order to run and query the data that needs to be updated on a daily basis, which is really painful for the workers and waste a lot of time. And in here, I will introduce you about the usage of the Apache Airflow. Apache Airflow is a tool that can be used as the monitoring tool, describing tool, as well as the executing tool to manage the workflow. And therefore, by using the Apache Airflow, the workers do not need to run the data mart update manually, and instead the Apache Airflow will do it for them. And as the monitoring tool, the Apache Airflow can be used to ensure the smoothness of the job execution because the workers can easily see which job were successfully executed and which one didn't. And as the describing tool, the Apache Airflow has a lot of the job or the tag tasks with a specific capability for their running of the job itself. And is in the executing tool, the Apache Airflow can be used to process the tag test or running the tag test, as well as considering its precedent constraints one to the other. And in the next slide, for this slide, I will simply introduce you about the real implementation of the Apache Airflow. Essentially, the Apache Airflow is used to manage the workflow, which is known as the tag task. The tag task in here stands for the directed acyclic graph. Acyclic in here means that this kind of the workflow do not have a cycle at all because it only has the start as the beginning as well as the finish as the closure for every tag task. And in here you can see this is just the simplest tag task or the Apache Airflow implementation at PTX. In here, it is used for updating the data mart of which is known as the layanan pendukung data mart with a specific capability. In here, the Apache Airflow has the capability to start the data mart, update, and censoring the newest data coming in, and so forth. But the most important thing that I want to note in here is that Apache Airflow can manage the precedent constraints one to the other. And it is also possible for the Apache Airflow to have the constraint precedence for one tag to the other tags, something like that. And in here, if you can see in the green side in here, it is actually indicated that those those tasks were successfully executed during that time. So since we do not really consider about the Apache Airflow in detail, but instead we will focus on the scheduling problem, then this is only just a brief introduction of it. Before we go further, let's just have some literature reviews to schedule this kind of the tech tests. Please also note that we do not have the simple problem like what we had in the previous slide because in the formulating the algorithm we try to have the more complex problem. And there are actually several scheduling principles that we have been familiar with. So let's say the most simple one, let's say if we only have one machine to finish the job, then the problem is relatively simple because we can only use the one machine problem to finish the entire jobs. And the drawback of using the one machine problem, although it is monetary efficient, but we cannot ensure about the total time that is resulting for it because it might exceeding the duration or the duration which is demanded by the users. And contrary, we can also have an infinite number of machines, which is known as the critical path method solution or the project evaluation technique. In here, it performs as the best case scenario because we assume that we have the infinite number of machines to solve the problem according to the precedent constraint and maximizing our goal, which is the minimizing the total time. Although it is, and although it can guarantee the optimal to aim the optimal total time, but using the critical path method solution, the company needs to pay the higher expenses to support the jobs because the less total time indicates the more machine to use, and the more machine to use indicates the more expenses to spend. Therefore, in this paper, we try to formulate how if we try to use only a finite number of machines, but we can still compromise with the total time. And instead of using the one machine problem as well as the critical path method solution, we will use the minimizing max span problem for this paper. However, the next challenge is actually that the minimizing max span problem is another NP hard problem, which is hard to find the global optimum solution, as well as there is no rule of thumb in solving this kind of problem. Therefore, heuristic algorithm approach is utilized to overcome this situation. And please also take a note that although we do not use the one machine problem and the critical path method solution, we will use both of these principles as our baseline in formulating the heuristic algorithm. And here is our goal actually is to minimize the resources that we exerted to support the job execution, but at the same time we are still able to compromise with the total time which is demanded by the users. So the total time is still reasonably good compared to only using the one machine as the extreme condition. And here in the chapter 3, I'll discuss about the heuristic problem. If you can see on the figure on left hand side here, this is just the deck test example that we use to formulate the heuristic algorithm. And as I have mentioned earlier, that in order to solve this problem, we will use the critical path method solution as the best case scenario, as well as the one machine problem as the other worst case scenario. And these two principles will act as the baseline for our heuristic algorithm. And solving this kind of problem for formulating the heuristic algorithm, we know that we can have only 3 machines to finish the entire jobs in here within the total time optimal total time, which is 58 minutes. Why? Because 154.5 divided by 58 is roughly 3 machines. Therefore, by only using 3 machines instead of the infinite number of machines, actually we can already settle with the optimal total time. But as I have mentioned earlier, that in this paper we try to formulate another heuristic to formulate the problem if we reduce the number of machines into less resources, which is in this case, we try to formulate the problem by using only 2 machines to solve the scheduling problem of that task. And please also take a note that our problem example in here, our tech task, actually few of the longer jobs, let's select job A, job D, and job F are actually at the beginning of the precedent constraint. And this uniqueness will be very important for our heuristic formulation. And here is the several steps for the first heuristic. The first step is actually we always measuring or calculating the critical path method solution. And it turns out that the critical path results the 58 minutes to finish the entire jobs, and we assign the critical path method tasks or jobs into the first machine or the VM1. And as I've also mentioned earlier, that we also calculate the total time if we only utilize one machine to solve the problem. The reason why we need to do this is to get the target total minimum total time that we would like to compromise for this situation. So in this case, is 77.5 minutes is our target total time. And in the next step is we try to assign another jobs that are not in the critical path method solution, but they also do not have any precedent constraint to the VM1. And the way we do it is based on the longest processing total time. And here is the example. So in this case, I can tell you that the critical path method solution is through the job D, O, R, O, Y, A, B, and so forth without job F. And in here, so let's just assume we have another jobs. Job A, B, C, E, F, and G are still available to be assigned either in the VM1 or the VM2. But our first heuristic algorithm says that we try to sort the remaining jobs that do not have the precedent constraint based on their LPT order, the longest processing total time, and we try to add those jobs one by one to the VM1 so that the adjusted total time is closest to the target total time, which is the 77.5 minutes. The reason why we use the LPT principle is because the LPT has the reasonably good worst case heuristic ratio for over 3. And therefore, in here, I can tell you that the only job F is assigned to the first machine because we have known earlier that the critical path method solution yields 58 minutes plus 20 will already result in 78 minutes. So we stop in this case because it is closest to the 77.5 minutes. And then for the yellow jobs in here, it will be assigned to the first machine, and the white circle, the remaining white circles will be assigned to the second machine. And then for the second machine, we use the head, body, and tail algorithm for those jobs that have the precedent constraint to the first machine. So in here, we create several sets. In here, there are 3 sets: A, K, and L in one set, G and M in another set, and Q, T, X in the other sets. The reason why we need to do this is because we need to consider that the job E, K, and L or a set must be finished before the job in the first machine started. And not only that, but we also take a note that, let's say in this condition, job Q, T, and X, although they need to be finished before job AA finish, but we also need to measure its release time because this set cannot be started before job O in the first machine executed or got finished. And furthermore, that our heuristic algorithm also limit or that every job inside a set must be done sequentially one to the other without being interrupted by the other jobs. So let's say in here, if we run the set A, K, and L, A, K, and L needs to be done sequentially before, let's say, job J can be executed, something like that. So after we are applied the head, body, and tail, then the remaining jobs that are not in the set can be scheduled by using the Lawler algorithm based on the longest processing time. Therefore, the job that has the longer duration will be assigned earlier than the job which has the less duration. And it yields this kind of the scheduling problem. You can see on the right hand side of the Gantt chart in here. So in the first machine, we have the job D, F, and so forth. And for the second machine, this is just the order. The drawback of the first heuristic algorithm, we know that the first machine in here performs slightly longer than the second machine, and it cannot reach the target total time, which is the 77.5 minutes, because by adding the jobs F will directly result in the higher total time. Therefore, we try to refine our algorithm and change the approach. Instead of adding based on the LPT order, we try to have the better approximation by using the knapsack problem. In here, the knapsack problem is that we try to add uh, the same principle, the jobs that do not have the precedent constraints into the first machine, or the jobs that are contains the critical path solution, so that the total time must be within the target total time, which is the 77.5 minutes. And the remaining steps are actually the same, but there are several changes that we need to consider. So let's say in here, so previously job A were assigned in the first machine, and now it is assigned in the, oh sorry, so job A previously were assigned to the second machine, but now it is assigned to the first machine. Therefore, the K and L is a standalone sets, and it cannot be grouped together. And job F in here is another set, something like that. But the principle are remaining the same. We still apply the head, body, and tail algorithm by measuring its release time whenever it is available, as well as the due date time when it needs to be finished within the total time. So the second heuristic algorithm yields this kind of the scheduling problem. Indeed, now we can see that the job in the VM1 can be finished within the target total time, which is 77.5 minutes, and the job in the VM2 is exactly finished within the in 77 finish on time. I mean, job in the VM2 can be finished on time, 77.5 minutes. Therefore, in solving this kind of problem, our final heuristic algorithm could catch the target total time optimally. But how if we try to apply our algorithm by only using two machines in the complex problem, let's say like this kind of problems in at PTX as well, we know that this kind of problem is more complex. So we try to compare the numerical experiments by running several trials. For the first problem, here is the performance of our heuristic algorithm. Based on the 95% confidence interval, it can be finished within the 78, on average 78.9 minutes with a deviation 2.67 minutes, and the average worst case heuristic ratio is 1.0038. However, if we compare to the our heuristic algorithm performance in the more complex problem, actually it has the longer, or it has the worst deviation, which is very high compared to this one, as well as the heuristic average of worst case heuristic ratio increases as well. Therefore, we also try to do some further calculation, and turns out that we know that the first problem could catch uh, the most optimal total time only by using three machines. Therefore, if our algorithm only considering two machines, then the results will not deviate a lot because it is close to the two machine. For the second problem, actually it needs five machines to finish the jobs within the most optimal total time retrieved from calculating the critical path method solution. Therefore, the distance between two to five machines are actually quite far away, and therefore our heuristic algorithm has the worst performance on it. So what we can summarize actually is that scheduling the tech test using the finite number of machines are actually NP-hard problem, and therefore there is no rule of thumb or exact solution that we can use to finish those jobs optimally. And in here, we utilize the heuristic approach by considering the critical path method solution as well as the one machine problem for our baseline. And our final algorithm surprisingly could catch the optimal total time for the first problem. That is naturally needs three machines to finish the job within the critical path method solution, but it has the deteriorated performance once the number of the required machine increases the total time. And will be the next in line for our research to refine the algorithm further if we have time. And last but not least is that the feedback that since we assume that the tech test can be sorted at any time and we do not consider the variation of the processing time, therefore it will be in line with our next research as well. So I think that's all that I can present and share with you, and thank you for your attention. And if you guys have any question, please feel free to interrupt me and unmute your mic. Thank you.